In this video, we're going to look at how to use the LatheEngraver along with a laser and the Profiler plugin in order to burn basket illusion lines, the horizontal basket illusion lines, in a very short amount of time. The first thing that we're going to do is we're going to turn our workpiece, and I have a couple of different views of this that you can see here, but you'll notice that I have not put the beads on this yet. And the reason for this is before we actually get to the point where we're going to put the beads on, we want to be able to have that surface profile. And to do that, we're going to use the scanning plugin. So the very first thing that we're going to do in this case is bring up the software. And you can see I've have the probe installed and attached on here. And the first thing that I like to do is verify that the probe's functioning. So you'll red on the LED here. Also in the pin section on the software there, you'll notice that it switches to P. That indicates that the probe is working how we anticipate. What we'll want to do is get this probe set up and get it oriented so that we're right on one particular edge. Now, in this particular case, I have the bowl mounted on a recess on the inside. You don't have to do it that way. In fact, you can do it the other way as well. You can have it mounted on this tenon and go the other way. The only thing to look out for in that case is that you need to make sure that you can actually reach everywhere that you need to go. So sometimes you might need an extension, or you need to move the LatheEngraver over in order to be able to get to the back side of your piece. Now, when we're in the LatheEngraver software, the first thing that we're going to do is we're going to go to the scanning plugin here. We're going to be doing an X scan in this case, and we're going to be moving in the positive direction, which is this direction. So this direction. So we'll leave that as positive. We don't need to have a reference diameter. That's only necessary when you are going to be making an STL file. Our scan length in this case we have to measure. So I'm going to put a ruler over the top of this and estimate what this is going to be. I'm going to put that at about 60 millimeters. So we'll enter this, 60. Our scan increments, we're just going to do 5 millimeter scan increments. Our pull off is how far it's going to pull off. We're going downhill here, so we can use a small value for that. And I'm just going to call this basket 1. We can also do ovality scanning, but I would say for basket illusions, there's almost no reason that you need to do that. So with this in place, the only other thing that I'll make sure that we do is that we drive the axis directly so that this first touch point is going to be right on the edge. So let me just drive this in and just verify that, yes, indeed, that is going to place that first point right on this edge, because we're going to use this edge for alignment later on. So I'm going to back it off just a little bit here, and then we will do our scan. So I go back to scanning here, and now I can just click Start Scan, and it will go through and do the scan. And it gives us our points in real time here. All right, and now our scan is done. And at this point, we would move our probe off here. We could take off our workpiece now, take it back to the lathe, and go ahead and put the beads on this wherever we want the beads to be. What I've done in this case is I put just a couple of lines, which maybe it'll be easier to see in this other view here. I have a line here and a line here, and then another line back over here. As that's kind of an indicator of where our bead limits might be for this particular piece that we're working on. All right, so now what we can do is disconnect our probe, take off our router, and we'll be mounting up the laser. All right, we now have the laser set up on the B-axis here. And just a quick note, when you're using the laser, it's always a good idea to make sure anytime you're done, you turn the power button off on the laser if it has one. So in this case, this button here, you can see the blue light means it's on. Or at a minimum, disconnect the laser itself when you power up the LatheEngraver. Because if you have everything on, when you first power on the LatheEngraver, you might get a quick pulse of the laser at full power, and you want to avoid having that happen. The second thing, as far as safety goes, is make sure you've got a pair of decent laser safety glasses that you're wearing at all times when you work with the laser. All right, so the first thing that we're going to do, at least with terms of the software mode, is that we need to make sure that we're set up in laser mode. So the latest versions of the LatheEngraver software have a toggle button here. So this is for the laser mode. If I turn this on, you can see now we have access to this weak laser button. That means we are in laser mode. If it does not have the weak laser button on, that means we're out of laser mode. So you want to make sure that we are in laser mode for this. The next thing that we need to do is we need to set our reference position, where our 0, 0 is going to be. And if you recall, when we did our scan, we started our scan right here. And so I'm going to go to the Profiler tab here first and look at this. And so this is where we're going to start setting this up. I'm going to go into laser mode, and I'm going to select our scan file, which was this basket file here. And that is our 0, 0 point. So what we want to do is we want to set our laser in focus at that 0, 0 point. So I'm going to go over here, and I'm going to drive this manually, in this case, over to that spot. Now I have set the B-axis to 0 already because I did that by eye, but I'm going to move this over to this spot. And in order to get this at the correct focal distance, it depends on your laser, but one of the things that they recommend is that the focal distance be about 40 millimeters where I have the camera. So I'm going to move this in until I'm about at 41 millimeters, which is about right here. And I can now turn on the weak laser button, and what I should see is, and I see just a little bit of the corner of the laser at that position. So that means I'm right at that spot, and so now I can set all of my axes here to 0. So everything has been zeroed out, and that is now consistent with that 0, 0 point here. All right, we can start filling in the rest of the information in the Profiler plugin. One important one is that we need to know the rotation distance from the center of the B-axis to the edge, the surface of the piece. So that includes the focal distance of the laser. So I've measured mine in this case to be 147 millimeters, and I've written this down on here. You can't see it in the camera, but just so that I remember what that is. Yours is probably going to be close to that, but you're going to want to measure that, and I have other videos that show how to do that. We next need to know how many segments we actually want. So how many horizontal lines are we going to burn? And this is going to depend entirely on the size of your beads, what shape you want those final segments to be. I'm going to set this to 160 here. That's kind of a lot, but we're only going to go through a certain distance. So as we'll see, I've got a couple of lines scribed on here. We're going to go from this line that you can kind of see right here to this line right there. So 160 going from there to there. Our feed rate in this case, I'm going to set this to a pretty high value, so this goes fairly fast. I'm going to set this to 1,000. And as I increase the feed rate, I would also need to increase the laser power. However, because this is just a demonstration, I'm actually going to decrease the laser power. I'm going to set that to 20 so we can see the laser as it traverses, but it's not actually going to do any burning. Now, the main thing that we do in this Profiler plugin and interacting with this profile is to set the markers. So we can set a max limit, and in this particular case, I'm going to guess where that max limit is. So you can use the ruler here to kind of gauge where that is on this profile. It looks like it's about 26 or so, so I'll put it 26.5, and then I'll set the min, and this min is going to be some relatively small value. I'll set it at about 2. It is a little bit hard to mess with these. No, I want it to be about 2.25, that's fine. But we want to know that those are the correct values. Does our laser actually hit the line that's representing the edges of our beads in this case? And in order to do that, we use the set target. So we can now go to this 2.25 that we have measured, and I can set the target there. And because we've zeroed everything here, and I'm just confirming that we're all at 0 in this case, we can just click go to target, and you can see this is going to move our axis and move into position, and we can verify that this is the correct position. So I'll move that in. I'll turn on the weak laser, and actually, yeah, I'm at 2.25. I'm right on that line, so that's a good position for that. We can go back to the profiler here and check our max position. So I'll set target again, and this is 26.5. So set target there. Go to target. You'll notice it does always move off. That's because it's making sure that it reaches a safe distance as it's going in. And we'll turn on our weak laser. And that's pretty close. It's a little bit to the left of that line, so I might scoot it over a little bit more, but for the sake of this test, that'll be fine. So we basically have everything set up and ready to go here because we have our min and our max limit set. I will say that there's a couple other things that you can do with the laser. You can do a test pass. If you verified the positions already using set target, you don't really need to use the test pass. It's just a sort of a legacy feature. And the other thing is in super advanced features here, this is the step size. So you notice we can increment by 0.25 millimeters, and that's what this sets. And there's also this B smoothing. If you find that you're getting more herky-jerky motions from your X and Z axes, you can increase this B smoothing. But the default, which in the current version is going to be 36, seems to work pretty well. So with all of those things set up, what we can do is simply click this write job. And this just takes a couple of seconds to show up here. Once we write that job, and there it is. We have our laser job. So this is 160 segments at a power of 20, and this was our basket illusion scan that we did, so we know that's there. So we're all set up. We're in laser mode, and now all we have to do is click start. And we'll see how long it takes to do 160 segments here. And you can see here we're 25% with the job. And so the total time for doing 160 of these lines at 1,000 millimeters per minute is probably just over 9 minutes. Now, I would say that 1,000 millimeters per minute is a little bit on the fast side. You probably want to go a little slower and decrease the laser power, particularly when you're starting out. And if you don't know a lot about the wood, you probably want to take it a little slower with lower power and do multiple passes if you need to. The other thing that I'd say is that depending on your laser, you're going to have your line thickness can be adjusted. One of the things that you can do is you could defocus your laser a little bit. So if you scoot it back further than that 40 millimeters, you can get a wider spot. Now, in that case, you're going to have to increase the laser power to get a thicker line or decrease the speed. So these are all things that you have to play with a little bit. And there we have it. It's finished up at 8 minutes and 39 seconds to do 160 segments, evenly spaced, perfect indexing.